Download this code from codegive.com, link in the description below. Tutorial on 622 Error Detection and Correction. Introduction. Error detection and correction are crucial aspects of communication systems and data storage to ensure integrity and reliability. One such method is the 6-2 code, which is a simple form of error detection and correction that can be applied to a 6-bit input. The 6-2 code is a systematic code that maps 6-bit data into a 8-bit code word. It uses 2 additional bits for error detection and correction. The basic idea is to add redundancy to the data in order to detect and potentially correct errors. How 6-2 code works. 1. Data encoding. Every 6-bit input is transformed into an 8-bit output. The first 6 bits are the original data. The last 2 bits are parity bits, which are calculated based on the first 6 bits. 2. Error detection and correction. The parity bits allow the detection of single-bit errors. If an error is detected, the system can correct it based on the parity information. Parity calculation. For the 6-2 code, we can use 2 parity bits. Parity bit 1, P1, this bit is set to 1 if the number of ones in the first 3 bits is odd, otherwise, it is set to 0. Parity bit 2, P2, this bit is set to 1 if the number of ones in the last 3 bits is odd, otherwise, it is set to 0. Example. Let's say we have the 6-bit data, 101011. 1. Calculate parity bits. For the first 3 bits 101, we have number of ones equals 2, even, so P1 equals 0. For the last 3 bits 011, we have number of ones equals 2, even, so P2 equals 0. 2. Code word formation. The resulting 8-bit code word is 10101100. Decoding and error checking. When receiving the 8-bit code word, the receiver needs to check the parity bits. 1. Received code word. Suppose we receive 10111100, 1 error occurred in the 5th bit. 2. Check parity. For the first 3 bits 101, number of ones equals 2, even, P1 should be 0 correct. For the last 3 bits 111, number of ones equals 3, odd, P2 should be 0 incorrect. Since the parity check fails for P2, an error has been detected. 3. Error correction. The system can identify which bit has likely changed based on the parity bits. In our simple example, we can deduce that the error likely occurred in the last 3 bits, so we can flip the 5th bit back to correct it. Code example in Python. Here's a Python implementation of the 6-2 error detection and correction. Conclusion. The 6-2 code provides a simple yet effective method for error detection and correction. This tutorial has covered how to encode data, check for errors, and correct them with a practical Python implementation. This approach is useful in scenarios where data integrity is paramount, such as in network communications and data storage systems. Feel free to experiment with the provided code and adjust it for different inputs to see how it handles error detection and correction.